following program is part of Cable in the Classroom, a free service of the cable telecommunications industry and your local cable company.
Hello, I'm Brian Kenny. Welcome to another ESPN Sports Figures, where math and sports team up. In our next segment, skateboard legend Tony Hawk and our Marissa Copeland skate into energy in the Sports Figures Classic.
Tony Hawk? Do you ever stop moving?
Sports Figures, put your brain in the game.
What happens when I drop this bowling ball down the half pipe? Okay, I guess we'd expect that. The bowling ball goes a little less high each time, and eventually, he's gonna stop. What happens when we drop him down the half pipe? He just keeps going and going and going. What is that? He should gradually come to a stop, just like the bowling ball. For years, people believed that they could create a perpetual motion machine. A perpetual motion machine would have the perfect balance of energy. Once it started, it would never stop. It would run forever, with no coal, no gas, no electricity, no nothing. But has Tony figured it out? What's the difference between a bowling ball and Tony Hawk? The bowling ball obeys the law of conservation of energy. The bowling ball, the half pipe, and the air inside the half pipe make an energy system. Conservation of energy means that energy within the system must be conserved. You can't gain energy or lose it. The total amount of energy within the system remains the same. Weird, right? But if energy can be neither created nor destroyed, why does it eventually come to a stop? Was this energy destroyed? Bronzy, what happened to your energy? This guy has plenty of energy. He's Tony Hawk. He's done everything there is to do in the world of skateboarding, and he has his own video game. So he's in perpetual motion. So Tony, what if you push off and coast? What happened?
Well, the friction between my wheels and the ground stops me. And there's also friction with the air.
So then was your energy destroyed?
Well, you just said that can't be.
But where did it go?
It was transferred.
Tony had moving energy, which is called kinetic energy.
The kinetic energy was converted to heat energy by the friction between the wheels and the ground.
See? The surface of the ball and the half pipe and the air that it encountered are all just a little bit hotter. The energy stayed the same, it just changed forms. So energy was conserved. Brunswick, you're running a little temperature. See, a half pipe is an energy conversion device. He has kinetic energy, KE, because he's moving. Now, some of that energy gets converted to heat energy, but as he goes up the sides, most of his kinetic energy is being converted to gravitational potential energy, GPE. If you push off and coast, you stop. So how do you add energy into the system so you can keep going?
You push off with your foot. To gain energy in a system, you have to do work.
In the half pipe, he's not pushing off at all, but he goes higher and higher each pass, so he must be adding energy to the system. As Tony comes down the wall, he drops into a crouch. Then as he starts to go up the other side, he extends his legs.
Well, to keep your speed up and to get height off the lip, you have to pump.
So that's what you're doing when you crouch down?
Right. As you drop down, you go down into a crouch, and as you go through the transition, you extend your legs. And it would only take me a little while. Start from down here and get to the top. That's how you do it.
So you're raising and lowering yourself. But how does that give you more energy?
It's just like pumping on a swing.
If I shorten on the upswing and lengthen on the downswing,
It starts getting higher.
yeah, what does that tell us?
It gains energy. It's kind of like Tony, lifting on the up part and dropping on the down part.
But lifting and dropping what?
Wait,
Okay, so somehow lifting and dropping weight gives us energy. How does that work? Every object has a center of gravity, or a center of mass. It's the average position of mass, or where the mass is concentrated. And for most people, it's right about here. Now, if I swing back and forth, just like this, no pumping, my center of mass describes an arc. But if I do this, see? Pumping is raising and lowering my center of mass by changing my shape. Because I raise my center of mass, I have greater potential energy up high, which gives me greater kinetic energy when I fall. If Tony stayed in a crouch all the way through the half pipe, his center of mass would only rise to here. But if he comes out of his crouch, extends his legs, he lifts his center of mass higher and gains more potential energy. Then, the further something falls, the more kinetic energy it has, right? Well, look, on the way down, Tony drops into a crouch. He lets his center of mass drop further. He falls longer than if he were standing upright. And before too long, Tony has enough energy to bring him all the way up here, above the rim, like this, to do all these really cool aerials. Greater potential energy up here, and greater kinetic energy down here. You can't change your shape, or raise your center of mass higher or drop it lower.
but wait a second. We said before that you can neither create energy nor destroy it.
We're gaining energy. Are we creating it?
Oh, good question. Is Tony violating the law of conservation of energy? No, because he's putting work into the system. Like when I pull on this string to raise the yo-yo and it swings, I'm doing work. And work puts energy into the system. Just like this machine. Coal gives up its potential energy to put work into the system to give it the energy to overcome friction and inertia. Right, Greg?
Right.
Check this out. When Tony straightens his legs, he's doing work. Lifting his center of mass is work. He's converting the chemical potential energy in his body to mechanical energy in his muscles to do the work to give him the energy to get him up the half pipe. That energy is what lifts him into the air. Oh, Tony, just straightening your legs doesn't seem like work.
Well, I'm not just straightening them, I'm lifting my body's weight. So just squat and lift a few times and you'll see that it's work. Force over a distance.
Oh, and here's a really cool thing. We can find the number that shows exactly how much energy your work is adding to the system by pumping. How do you measure energy? We measure in joules. How much is a joule? A joule is the force of 1 Newton exerted over the distance of about 1 meter. This orange weighs about 1 Newton. That's the metric equivalent of weight. And if I lift this orange over my head, that's about 1 meter. So, lifting this orange takes about 1 joule of energy. Now, if I eat this orange, that's going to give me 420,000 joules of energy from the calories. So, eating an orange allows me to lift an orange about 420,000 times. Let's see. 1, 2, 3. How do you start in the half pipe?
Well, I stand on the top and then I just drop.
Okay, let's figure out your gravitational potential energy. No, it's a really simple equation. It looks like this. GPE equals weight times height. So, how much do you weigh?
I weigh 700 newtons,
Yeah, now, how high are we here?
about 15 feet.
Tony's center of mass is here, about 3 feet higher than the rim, so 18 feet. Let's call that 5.5 meters. Well, to find his GPE, we just multiply Tony's weight, 700 newtons, by his height, 5.5 meters, to get 3,850 joules of potential energy.
Wow, let's turn that into kinetic energy.
Okay.
Go for it.
That means that down here, Tony will have a little less than 3,850 joules of kinetic energy because of what's lost to friction.
Now, Tony's center of mass is way up here. He's even lifted his legs to get as much of his weight as high as possible, just like on the swing. Now, because he's higher, he has a new GPE, and we can figure that out.
Tony's center of mass is now 6.5 meters from the bottom of the half pipe. His weight hasn't changed, 700 newtons, so 700 times 6.5 is 4,550 joules of potential energy. His energy is greater.
We know that Tony added at least 700 joules of energy to the system.
Oh, actually, that makes sense, because lifting my center of mass out of a crouch is lifting 700 newtons, about a meter, and that would be 700 joules.
Right.
Well, that's cool.
Physics is totally cool. So, a boarder in the half pipe isn't a perpetual motion machine. He is obeying the law of conservation of energy. Everything's okay here, officer. Okay, guys, what did we learn?
That in a system, energy must be conserved. That's a law of conservation of energy.
Energy can't be created or destroyed, but it can be converted or transferred to other forms.
But no practical, real system can go on forever without adding energy. And when you add energy, you do work.
Tony in the half pipe. Types of energy are gravitational potential energy, kinetic energy, and heat energy.
And work and energy are measured in joules.
Okay, good work. Hey, we said energy can neither be created nor destroyed, right? So where do we get the energy to do the work to lift your weight?
Your muscles use calories to do that. Calories are like joules, a unit of energy you get from food.
So we can even figure out how many calories of energy you use to lift your weight each time.
That'd be cool.
Well, that's it. We'd like to thank Tony Hawk, 2001 Next Cup champion Alan Young, and our students from Carlsbad High, Dusty, Andy, Liza, and Emily, for helping us out here today on ESPN Sports Figures, Perpetual Motion.